This is a transformer, and it's 115,000 volts comes into one side and 34,500 volts comes out of the other side. And inside this transformer, it's all pretty close to each other with different phases and tight coils and windings. Did you ever wonder how that can happen without it arcing over or blowing up? Well, I never did until I started working in these yards, but now I know, so I'm going to share that in case you ever wondered. So inside this transformer, it's filled with an insulating oil, and that insulating oil it has a high dielectric, and it keeps the electricity from arcing over. The thing is, you have to allow for that oil to expand and contract, because as it gets hotter or cooler, it expands and contracts. So we can't fill it completely up, or at least in this instance, this type of transformer, this is what's called nitrogen blanketed. And on the very top of the transformer, there's what's called the headspace. Everything electrical is mostly below it except for the leads going into it, which are still insulated as they go in. So on that headspace, it's got what's called a nitrogen blanket, which is just pure nitrogen, no oxygen. And there's a bottle over here on the side of the transformer with the nitrogen in it, and it keeps between 1 and 3 pounds of pressure inside that transformer, which allows for the oil to expand and contract as it cools and warms inside that transformer. And there's a little regulator, and so it can escape if it has to into the air, but it does not take moist, oxygenated, normal atmosphere inside the transformer. It's kept with this dry, non-arcing, insulating nitrogen, pure nitrogen. And that's how it works. Hopefully that explains something if you ever had a question.